Hello and welcome friends. In this particular module, we wish to discuss about the sources, classification, composition and characteristics of municipal solid waste. As you learn the content, you will be able to explain the inflow of the solid waste in the society, state the typical contents of municipal solid waste according to the category of the source, and also explain the approaches for quantification of municipal solid waste. As we consider this particular flow diagram, you will be able to understand how and what stages there are chances of generation of the solid waste. Let's consider this particular, say, central blocks which are depicting some process in which certain raw material is employed. It is used for certain manufacturing process. As such, this particular raw material is converted into some product. That product is used by certain user. As this particular product is used and when it ceases its utility value, it will be transformed into the waste. Hence, beyond this particular point, there will be requirement of the disposal of that particular waste. As well, as we consider this particular point of initiation, all the raw material that is brought in order to manufacture certain product may not be used. Some of it could be useless as such. Hence, as we think about this particular first step, from that point itself, it is quite probable that there will be some residual waste and it will be coming out of the process. Similarly, as we consider this particular, say, manufacturing transforming process, though material is employed in the form of raw material, all of it is being processed here. Out of that particular processings, again, some residue will be coming out of. Also, as we consider this particular, say, left wing of this particular flow diagram, in order to manufacture something, we are making use of some energy. As this particular product is manufactured, it undergoes certain processing as well as certain recovery, and through that particular chain it will be entering in this particular central process which is leading to the consumer. Also, during the processing of the waste or during the recovery aspects, some of the waste will be generated and hence this particular waste needs to be disposed. As we consider this particular right wing, also after this particular manufacturing there could be need of certain secondary processing, and out of that secondary processing also some of the waste will be coming out which will be again joining this particular waste stream. So, in general, as we consider this particular, say, flow diagram for a society, at the various places, waste will be flowing out of the various processes being followed as a general activity of a certain society. In order to just understand the typical waste generators and their respective contents, we can refer to this particular table. Here the way you see, the sources are defined as residential, industrial, commercial, institutional. And in addition, here just on the right side, as you see here, we have considered certain construction activity as well as certain municipal services, certain processes, and even the agricultural activity. Serially, there could be single or multi-family dwellings as far as residential waste is concerned. For industry, there could be light and heavy manufacturing, fabrication, and such generators. For commercial activity, there could be certain stores, hotels, restaurants, markets, office buildings, etc. For institutions, there could be certain schools, hospitals, prisons, as well as certain government centers. As far as this particular construction and demolition waste is concerned, there could be new and old construction activities. There could be number of municipal services associated with the street cleaning, landscaping, maintenance of the parks, beaches, and other recreational areas, water and wastewater treatment plants, and such things. Also, there would be various processes associated with light and heavy manufacturing, refineries, chemical plants, power plants, as well as mineral extraction and processing, and lastly, the agricultural activity. As you see, each of these particular sources and these particular typical generators, we can have these particular solid waste content defined according to that particular source and this typical waste generation. As we are dealing with this particular municipal solid waste, we are more associated with this particular residential source and partly say these particular municipal services. So, as we consider this particular residential activity, the contents could be food waste, paper, cardboard, plastics, textile, leather, yard waste, wood, glass, metal, ash, and certain special waste like bulky items, consumer electronics, batteries, oil, tires, and certain household hazardous waste. As we got introduced with the municipal solid waste, here we don't wish to have these particular consumer electronics or in general household hazardous waste as part of municipal solid waste. Hence, the entire municipal solid waste can be broadly classified as biodegradable, recyclable, inert, certain composite waste, and domestic hazardous waste. So, the respective contents are shown in front of each of these categories. Also, we can have this particular municipal solid waste classified based on its type as garbage. We know garbage is nothing but the food waste, as well as rubbish, street sweepings, construction and demolition waste, bulky waste, then municipal services associated with this STP, then dead animals, ash and residue, farms, gardens, and some abandoned vehicles. This composition of municipal solid waste is very critical phenomenon. Basically, we want to have that studied in order to plan as well as design certain municipal solid waste management system. However, the composition is considerably affected because of the recycling aspect, reuse aspect, as well as recovery aspects. As you see here, we are making use of some source related with this particular CPHEO manual for India. It is for 2005. As we consider from some different source, say here 2005, here the way you see the waste configuration and the way the waste configuration presented here is different. Say for example, here this food and garden waste is clubbed together. It could be, say, required to think about the biodegradable content, and that's why it could have been combined. However, as you see here, from a different source, the biodegradable waste is expressed to be 47.4%. In the same year, as you see here, the paper content is 8.13%. However, as you see here, the paper content is 27%. So, what I mean to say is, this particular waste composition vary considerably, not only between the cities, but also within a particular urban local body. Also, the changes occur daily, season wise, as well as even there are lot many temporal fluctuations. Hence, as we see this particular typical composition, according to one's interest, one must go for actual sampling over the seasons, and certain quantities can be studied in order to express the composition valid for that particular period only. Because the way you see here again, in 1996, the biodegradable content is expressed to be 42%. It is increased in 2005 to be 47%, whereas as we go to this particular 2011, again the waste content which is biodegradable in nature is around 42.5%. Here, there is a substantial difference in the values of the paper content, 3.63%, 9.63%. The plastic rubble observed in this particular 1996 is 0.6%, whereas as we consider 2011 data, it comes to be 10%. Hence, even as you see the expressions, there is no certain common platform, common policy in order to decide this particular composition. As you see here, we have to study this particular composition for number of things. The way you see here, as the waste is collected at the generator end, if it is in segregated forms, further it needs to be stored. Hence, this storage could be for non-recyclable materials, for organic materials, for plastics, for papers, as well as say for metals. So this is just for example. So depending on the composition, we can adopt certain, say, storage facilities. As well as this particular waste is stored, then subsequently it needs to be collected as well as transferred. So what kind of means is to be used in order to have that particular waste collected? So what kind of the capacity is to be used? Whether we have to go for rear loading, whether we have to go for the front loading, whether we have to go for side loading, and accordingly, so the means we can decide. As well as we have these kind of materials and as we know the composition, we can think about its potential for the resource recovery. Say for example, whether that particular waste is to be burned, incinerated in order to obtain the energy, in order to obtain the fuel, in order to go for the power generation. So this study helps us to determine the potential for the resource recovery. As well as we consider the type of the way, say these particular waste, depending on its biodegradability, depending on its inertness, we can decide the frequency of collection. Say for example, if the waste is generated in certain vegetable market, in some restaurant, say if there is some large content of food, it is quite probable that it would be decomposed immediately, and hence it needs to be collected daily. Whereas as we think about certain inert content like glass, plastic, etc., we can go for say weekly collection or 15 days collection or once in a month, depending on the quantity of the waste generated. Also, as we think about storage, collection, resource recovery, so whatever that remnant is there, that remnant needs to be disposed. So whether to go for certain landfill, incineration, compaction, certain anaerobic digestion, composting, vermicomposting, or any kind of such disposal method. So there are many innovative thoughts which can further be employed in order to deal with a particular waste being developed with certain composition. Here on the earlier side, we just discussed about the variation. So as far as Indian circumstances are concerned, it can be seen here that the compostables are ranging in between 50 to 52%, recyclables 16 to 22%, inerts 28 to 33% from the various parts of India like east, northern, south and west regions. Similarly, that particular composition could be studied from the metro regions as well as certain, say, other cities. As I discussed previously, one should apply the logic and clearly understand what is included in this particular compostable, recyclable as well as inerts in order to avoid the confusion among the data that is obtained region-wise. As we are interested in determination of this particular composition, it can be studied in the field itself. However, the solid wastes are complex, that are multi-phase mixtures. It has got heterogeneous nature, and hence the determination of the composition is that way difficult task. As we are dealing with these particular complex multi-phase mixtures, It is not easy to apply the statistical procedures as it is. However, on the field, we can follow some random sampling method or coning and quartering method in order to have this particular composition studied. Here again, one can follow various approaches. The way you see here, the waste is arranged over these particular 9 squares. So out of that particular 9 squares, one square is adopted. Further, that particular square is divided into the 4 parts. As such, one quarter is chosen, which is assumed to be representative of that particular entire waste. As such, this particular composition will be studied, and further this particular process would be repeated in order to represent the waste for a urban local body. In the similar manner, we can go for certain landfill studies on which we can have certain cylindrical masses, we can have certain, say, conical masses spread over a particular region of that particular landfill, which will be giving the typical configuration that is existing in that particular place. As well, even we can think of the waste deposition strategy time-wise. Say, for example, if we consider this particular cylindrical mass, the bottommost waste will be old one, and hence, as we studied the composition, it will be giving us some, say, information about the practices being followed earlier while disposing that particular waste. As you see here, the entire waste is divided into these particular 4 parts. Out of that, these particular 2 parts are chosen. These particular 2 parts are further mixed. Further, they are divided into 4 parts, and again the 2 parts are chosen. As such, one can follow different methods such as random sampling, coning and quartering in order to know the composition in the field. So, based on these particular studies, one can estimate the average data from several samples that are collected periodically over 7 days at multiple representative locations within the jurisdiction of certain urban local body. So, as it is studied season-wise in the summer, winter, rainy, etc., it will be giving us certain representative nature, composition of the waste being generated in the jurisdiction of that particular urban local body. So, as such average quantities are obtained, that can be further extrapolated in order to represent it as the composition of waste valid for that particular urban local body. Once again, I would like to repeat that this particular process is very dynamic. The waste generation factor is very dynamic. So it needs to be monitored continuously so that one will be able to understand the effect of the various factors that we studied about the generation of the waste. As we are interested in knowing this particular stream of municipal solid waste in order to know its nature, particle size, composition, and even its quantities, there is a necessity of involvement of certain logical as well as systematical approach to obtain and analyze the data on number of streams or its substreams. Usually, this particular analysis, the way I mentioned earlier, it is helping us in order to obtain the composition as well as the quantity of that particular waste. Unfortunately, there is no agreed international standard, and hence the way we see the various literature, the term refuse, rubbish, solid waste is interchangeably used and it may create the confusion. Say for example, if we think of garbage and rubbish, we define it in certain way. So as we consider trash, we are thinking the definition of the trash in certain way. So that needs to be implemented in order to avoid the confusion among the data points. As we are interested in determination of the quantities, here one can follow two basic approaches such as material flow approach and site specific study approach. Let's try to understand the features of this particular material flow approach. Here, the production data by weight are collected for the materials and the products in the waste stream. Also, the adjustments are made for the imports as well as the exports and material diverted from the stream. Also, adjustments are considered for the lifespans of the various products. Let's consider a simple example for one of the constituents of municipal solid waste, say for example paper, cardboard and similar thing. So it is being produced out of this particular domestic activities. So some of that particular paper, cardboard, etc. could be used for, say, packaging something. So it is being converted and accordingly it is moving out of the stream. Say, as we consider this particular cardboard itself may be in need of packaging. So as it is bundled together, we can be going for certain metal straps, we can be going for certain rubber straps, we can be going for certain, say, woven straps in order to have that converted into neat bundle. As such, we are importing the material in order to have that particular waste transformed into bundle. Such bundle could be partially exported and hence it is moving out of the stream. Certain residue that is remaining could be getting diverted out of the process. Say for example, if there is certain kabadi wala, if there is certain, say, rack picker who is interested in getting that particular paper, so it is getting permanently out of a particular flow. Whereas if certain content which is used for the packaging is re-entering in the stream, it could be considered as, say, temporary diversion. As such, at the end, that material will be treated as the generated waste. Here, as we are concentrating on the material and the related products, we have to additionally think about the materials such as food waste, yard trimmings and certain miscellaneous inorganic waste being generated, and that should be added in the entire flow in order to represent the municipal solid waste being generated. The second approach is site specific study. This particular study involves the sampling, sorting as well as weighing of the individual components of the waste stream. So the way we considered about that quartering techniques, coning techniques, so that techniques can be adopted here and accordingly the waste can be expressed in the various constituents in the fragmented form. So this particular method is very useful in defining the local waste stream. The site specific study requires large number of the samples. So the way we consider that this particular sampling, random sampling especially, is to be done over the period for a particular site, over the seasons, in order to understand the seasonal variation as well as temporal variation and such things. So accordingly, here it needs the large number of the sampling. Also, we wish to have this particular sample representative type so that the results won't be skewed and misleading. In addition to this particular sampling, usually the site specific study is preceded by certain questionnaire survey. So this particular questionnaire survey usually collect the information in the form of age, income, opinion, size of the family, and similar aspect of the generators who are related with the solid waste. Also, as we obtain the quantity, as we know the nature, as we know the composition of the solid waste, now the next part is to plan, design, and subsequently operate and monitor certain municipal solid waste management system. Hence, we have to further go for characterization of municipal solid waste. It is very important step for the implementation of collection, processing as well as disposal of that particular solid waste. This characterization can be brought under physical, chemical, and biochemical characteristics. As we move ahead, we will discuss more about each of such type of characterization. So, thank you for your attention. I hope you have understood the concepts I tried to put forth. So, as we move ahead, in the next presentation, we will discuss about the physical characterization of municipal solid waste. So, bye till then. I wish you very happy learning. Thank you.